Okay, we made it to the last section of for chapter 5. This is 5.6b on your video, and this is perpendicular lines. So two lines are perpendicular if the product of their slopes is -1. Now, what I'm going to be saying is they are opposites and reciprocals. They're both opposites and reciprocals. So a horizontal line and vertical line are also perpendicular. So a horizontal line looks like this. A vertical line looks like this, and they are perpendicular. Perpendicular means that they form a 90-degree angle. So that's what these particular lines look like in real life. A vertical line and a horizontal line are perpendicular, or any two diagonal lines that their slopes are opposites and reciprocals are also perpendicular. All right, so let's look at some examples. We have 6 examples. First example, we're looking at two lines and trying to determine if they are parallel, perpendicular, or neither. If they are parallel, they have the same slope. If they are perpendicular, their slopes are opposite, means different signs, and reciprocals. Remember, reciprocals are like 2/3 and 3/2. They're flipped. 2 and 1/2. Those are reciprocals. 1/2 and 2. You want to think about that. They're also going to be different signs. So one of them has to be negative and the other one has to be positive in order to be perpendicular. And then neither would mean they're neither one of those. They're not parallel, they're not perpendicular, they're not same slopes, they're not opposites and reciprocals, so they're neither. So you're going to need to find the slope of each one of these lines. So the slope of this line, since it's solved for y, is the coefficient of x, so that's 1. The slope of the bottom line is -1. Now, we don't think of this, but those are opposites, obviously. One's positive, one's negative, but 1 is also its own reciprocal. If you were to flip 1, you get 1. So +1 and -1 are opposites, and they're reciprocals, so this is perpendicular. These two lines are perpendicular. Okay, now in this particular situation, remember Vux-Hoy. If both equations are y, that means we have two horizontal lines. So two horizontal lines are parallel to each other. Okay. On this particular situation, we have one of the equations is in standard form. So I need to take that equation and I need to solve it for y. So subtract x. And I get -8y equals -x minus 7. Divide by -8. And all I'm looking for is the slope. A negative over a negative is a positive over a positive. This coefficient of x is a 1. So that's 1 over 8x plus 7 over 8. So the slope of the top equation is positive 1 over 8. The slope of the bottom equation, since it's already solved for y, is 8. Now don't let this fool you, okay, because these are actually not opposites. They're just reciprocals, so that means that they're neither parallel nor perpendicular. In order to be perpendicular, they have to be opposites and reciprocals. Okay, so that's a few of the examples for those. Now let's look at writing equations again. So when we write equations, we want to look and see, do we have the slope that they want us to have? So write an equation, slope-intercept form of the line that passes through the given point and is perpendicular to the graph of the given equation. So that means we need to find the slope of the given line, which, since it's solved for y, it's -7. But we're going to flip it and change its sign. Now there's a little symbol for perpendicular. It's an upside down T. So the perpendicular slope is where you flip it and change its sign. So it's 1/7. All right, 2. So on this one, do they give us the y-intercept? Well, they do, because remember, when x is 0, What is y? Y is 0 in this equation. So we have b. Now, if you don't have the y-intercept, you're going to have to plug it into point-slope form. But in this particular equation, they do give us the y-intercept. So we have the slope and the y-intercept, which is just y equals 1/7 x. And all we have to do is type 1/7 x. All right, now this one, they don't give us the y-intercept. So this one, we are going to have to do a little bit more steps. So first, let's find the slope of the given line. Again, they're nice enough that they have it solved for y for us. So the slope of the given line is 1/2. But we want the perpendicular slope, because again, it says perpendicular. So flip it and change its sign. So we're going to use -2 for our slope. They don't give us the y-intercept this time. Boo, I know, but we can find it. We're good like that. So y minus y1 equals m parentheses x minus x1. So if you don't have the y-intercept, you've got to go through the point-slope form. So y minus 2 equals the slope we're going to use is -2 parentheses x minus -2. A lot of 2's. All right, so we're going to do the distributive property because we want our answer to be in slope-intercept form, which is y equals mx plus b, which basically means solve for y. So -2x minus 4, add 2. So the slope-intercept form of the equation that's perpendicular to the given line and goes through -2, 2 is y equals -2x minus 2. All right, so far so good. One more. A path for a new city park will connect the park entrance to the main street as shown to the right, okay? As shown over there. The path should be perpendicular. That means we need opposite and reciprocal slope to Main Street. What is an equation that represents the path? All right, if it's perpendicular to Main Street, we need to first find the slope of Main Street. So the slope of Main Street, oops, let me do one more of those. Okay, so let's find 2 points. All right, so one point on Main Street is there. Another point on Main Street is right there. So the slope of Main Street, we're going to go up 2 and then right 1. Since I went up 2, that's +2 over right 1, that's +1. So the slope of Main Street is 2 over 1. But I need to know the perpendicular slope because it says perpendicular to Main Street. So flip it and change its sign. So we're going to use -1/2 for m. Now, it goes through the point on the right. It's going through the park entrance. So the park entrance, that point is the y-intercept. Okay, so that's B. We already have what the y-intercept is. Now, if the point is not the y-intercept, you're going to have to use point-slope form. But in this case, it is the y-intercept. So we're just going to use y equals mx plus b. Y equals the y-intercept, the slope is -1/2. That's the perpendicular slope. Plus the park entrance, that's actually the y-intercept, so that's 4. So they already have the slope the y equals for us. All we have to do is type -1/2 x plus 4. So remember, if this park entrance or whatever that point is it's going through is not the y-intercept, then you have to use point-slope form. Okay, so point-slope form is when there's not a y-intercept. All right, so that is all of these notes. You are now ready to do the homework problems.